Hello everyone, hope you're having a great day wherever you are. Here in today's presentation, we're going to talk a little bit about Ethereum, specifically, just like it says on the screen, what is Ethereum? Again, my name is Mark. You can check out more information about me there at my link tree. And I'm really excited to talk about this subject because Ethereum does share a lot of their core values with the Uniswap Foundation. And I want to make sure to do my due diligence and make sure that we discuss both Ethereum and Uniswap, since they have such similar core values and are such effective pieces of the decentralized finance ecosystem. So let's jump into it, and I thank everyone for being here. I'll mention a little bit later in the video a little bit about smart contracts, and I've already uploaded my first couple of videos on smart contracts where we created a counter contract. If you want to check that out in my videos on my YouTube page. So again, let's jump into it. I appreciate everyone for being here. So here we'll just kind of give a brief introduction. Again, welcome to the presentation on the Ethereum and blockchain technology. Today, we'll be discussing what Ethereum is, what a blockchain is, what is in a block on the blockchain, and the fundamentals of blockchain technology. The concept of decentralized digital currency, as well as alternative applications like property registries, has been around for decades. Whether you're a beginner or familiar with these concepts, there's something to learn for anyone interested in how blockchains work. And I'll put a little snippet there from Investopedia, and that quote I placed in the center. It's from the Ethereum.org website, which I've referenced a couple of times here in this presentation. They have some excellent educational resources if you want to just learn about Ethereum, or you're interested in writing smart contracts. But please feel free to reference any of these sources that we share with each other today. So, simply, what is Ethereum? Ethereum is an open source, blockchain-based platform that enables developers to build decentralized applications, otherwise called dApps, a lot like apps, applications, or dApps. It was created in 2015 by Vitalik Buterin and has its own cryptocurrency called Ether. So as the graphic illustrates, there is a third party that usually is which is kind of a bridge or a barrier for entry for developing things programmatically, like these smart contracts. And you can see how traditional contracts require a third party, often at a cost to the user or to the company using them. And you see how smart contracts are a way to get rid of that third party, reduce costs, and increase trust in the process. And we'll learn a little bit about how that smart contract, if there's how smart contracts are immutable, can be safe for the user to use. Okay. So again, we're just kind of going over these simple questions, like what is Ethereum? The next one, what is a blockchain? A blockchain is a decentralized distributed digital ledger that records transactions in a secure, immutable, and transparent way. I included a screenshot here today of a it's called a scanner, and it's a way for users to interact with the blockchain if they want to, or they can simply, and this is what it's used for mainly, is to find transactions and have a kind of a recorded history of these things. There's always a way to look these things up with smart contracts on sites like Dune, for example, or Remix. But Etherscan makes it simple for the user just by searching hash addresses or wallet addresses that look a lot similar, but again, they exist as the technology exists for different purposes. Excuse me. So next, each block in the blockchain contains a set of transactions and a unique identifier called the block hash, which is generated using a cryptographic hash function. And so again, the Etherscan user interface has been improved upon year after year. And right now they're in a place where it still is a little difficult to understand for a new user. But as you start to understand how your first wallet works, how your first transaction is broken down, you'll start to see why Etherscan is such a powerful tool when you start to understand the blockchain. So, what isn't a block on the blockchain? Now we're just getting to the specifics. No graphics on this slide or anything like that, because I just wanted to focus on these key definitions here. So, a block on the blockchain consists of three primary components: the block header, the transaction list, and the block hash. The first of which, the block header, contains metadata about the block, including the block hash of the previous block, the timestamp, and the nonce, a random number used in mining. To expand upon that phrase, nonce, this is a one-time secure number that's used to authenticate that type of transaction. Next, again, the transaction list. This contains a set of verified transactions. These are those smart contracts being written. These are those transactions going on the blockchain. Lots of different types of activity that you can do on the blockchain. Next, the block hash, which is a unique identifier for the block generated using a cryptographic hash function. So here's a little bit of a illustration to make it a little bit more simplified. From a programmatic standpoint, it looks a little bit different than this, but this is just for our educational purposes today, and this is just an example of how data looks when we're mining Ethereum blocks. And so you can see that each transaction contains a copy of the last one, and you can see the nonce is unique as well. So again, the Ethereum.org website, I've referenced this quite a bit. I think we'll even see it again. A great resource, and it was one of the most excellent resources to use when I first started to learn about blockchain technology in Ethereum, and now today when I'm getting a little bit more hands-on using Remix and Solidity. So, to differentiate Bitcoin from Ethereum, I included this illustration for some of our viewers today. And this just shows how the reward system breaks down when a user is mining for Ethereum. And I believe this is an illustration for the old proof of work system. Now we're on a proof of stake system, whereas the proof of work required you to have your ETH always in liquidity, and then when you have it staked, the Ether would be locked up into a contract. I mean, I may have the first one mistaken, but we're gonna look at the consensus mechanisms here in a little bit. So apologies if I made a mistake there. So again, this is a quote from the Ethereum.org website. The Ethereum blockchain is in many ways similar to the Bitcoin blockchain, although it does have some differences. The main difference between Ethereum and Bitcoin with regard to the blockchain architecture is that, unlike Bitcoin, Ethereum blocks contain a copy of both the transaction list and the most recent state. Aside from that, two other values, the block number and the difficulty, are also stored in the block. So these are those core values shared with you earlier, and they may look a lot similar. They may look very similar if some of our viewers are here from the Uniswap presentation. The fundamentals of the blockchain technology: decentralization, immutability, security, and transparency. And I'll go over these because these are very, very important. When you bring this type of philosophy into the technology that you use, you can make some incredibly democratic tools for everyone to use. And really, again, going back into our financial why we do these presentations, gives you control over your finances and helps you to be a consumer that has control over their everyday liquidity. So this point about decentralization, blockchains are decentralized. This means that they operate without a central authority or intermediary, enabling peer-to-peer transactions. Anybody can use them. Immutability. Once data is recorded on the blockchain, it cannot be altered or deleted without consensus from the network. That means that there's incentives for honesty. Security. Blockchains use cryptographic techniques, including hash functions and digital signatures, to secure and verify transactions on the network. Transparency. All participants on the network can view all transactions, promoting transparency and trust. And again, like I said, stated before, promoting more honesty, more honest activity on the network, on the Ethereum network. Oh, and just to show, I included a screenshot of Uniswap because again, very similar core values, and they deserve that same kind of credit for extending upon that philosophy when they built the technology that everyone uses today. Their automated market maker, Uniswap. So here, we're going to look at the definition of a couple different consensus mechanisms. First, the proof of work, and then the proof of stake. So just to kind of go through these, so we can take a look at the website together. Ethereum uses blockchain technology to power its network and enable developers to build dApps. Ethereum's blockchain enables the execution of smart contracts, which are self-executing digital contracts with the terms of the agreement directly written into lines of code. The Ethereum network has undergone several upgrades, including the recent transition from proof of work to proof of stake consensus mechanism. And you can see that POS is short for their titles. The transition to proof of stake aims to improve scalability, security, and energy efficiency on the network. With proof of stake, validators are chosen based on a number of cryptocurrency tokens they hold, rather than the amount of computational power they provide in proof of work. So excuse me, it wasn't about the amount of ether. It was just the amount of computing power they brought to the table when mining from the Ethereum network. So let's take a look at how that works specifically. I appreciate everyone's patience. It'll take just a moment to load here. All right. So just to kind of go over some of the important points here. The proof of work based system. Like Bitcoin, Ethereum once used a proof of work based consensus protocol. And this is how the blocks were created in the Bitcoin network. Miners compete to create new blocks filled with processed transactions. The winner shares the new block with the rest of the network and earns some freshly minted Ethereum. The race is won by the computer, which is able to solve a math puzzle the fastest and the most complex mathematically. This produces the cryptographic link between the current block and the block that went before. Solving this puzzle is the work in the proof of work is the work in the proof of work, in quotes. The canonical chain is then determined by a fork choice rule that selects the set of blocks that have had the most work done to mine them. And there's a little bit about security. But we're just defining the difference between proof of work and proof of stake. There was a lot of conversations when this change happened because we're saving energy now using the Ethereum network. Before, it was extremely heavy and consumed a lot of energy. Now it doesn't. And so that being a kind of a big talking point or a point of contingency, just to educate on it, educate some of our users on that. It's not anymore. It actually can empower you to learn something, and it can save energy in the process as well. There's even stuff to learn about how you can use cryptocurrency to purchase carbon credits if you want to look into research about that. So again, you will find when you're having conversations like this, energy usage might come up for the everyday user, and this is how you can educate them on that. So let's go further down and now look at proof of stake. Ethereum now uses a proof of stake based consensus protocol. Validators create blocks. One validator is randomly selected in each slot to be the block proposer. Their consensus client requests a bundle of transactions as an execution payload from their paired execution client. They wrap this in consensus data to form a block, which they send to other nodes on the Ethereum network. This block production is rewarded in Ethereum, or Ether, excuse me. In rare cases, when multiple possible blocks exist for a single slot, or nodes hear about blocks at a different times, the fork choice algorithm picks the block that forms the chain with the greatest weight of attestations. And this is again where weight is the number of validators attesting scaled by the Ethereum balance. And so again, this is just a way of saying this is how the math is going to work in a proof of stake type of system. It's a little bit more difficult to explain because these things they're computer programs. This is software. It's not the easiest thing to talk about a computer language in regular everyday speech. I talked about this earlier with a friend, but the more we educate ourselves on these types of things, we can take some control back of the abstractions they sort of become when we do get lost in things we perhaps some of us can't study every day, like JavaScript or Solidity. Some of these things I've mentioned to some of our users. But again, this is a great starting point here. You can learn a little bit about Ethereum, Ethereum's history at ethereum.org. And here as well, you can see that there's a great way to read through the website and not be distracted. All right, so we'll jump back into our presentation here. And I thank you for everyone who's watched so far. We're jumping right back into it. We'll be done quick. All right. So again, we've covered the proof of work and proof of stake. We'll move on to our final thoughts here. And I thought these were some of the most important points. Ethereum is a blockchain-based platform that enables developers to build decentralized applications. A blockchain is a decentralized distributed digital ledger that records transactions in a secure, immutable, and transparent way. A block on the blockchain contains a block header, a transaction list, and a block hash. The fundamentals of blockchain technology include decentralization, immutability, security, and transparency. Ethereum uses blockchain technology to execute smart contracts and validate transactions on its network, utilizing a consensus mechanism called proof of stake since its recent upgrade. The Ethereum network has undergone several historical upgrades, including the transition to a proof of stake system, and this improves scalability, security, and energy efficiency. So again, these are just some points I thought would be important. And again, a sincere thank you to all of our viewers. I want to mention again, there's a video where we look at a simple counter smart contract where we just make increments and decrements to a specific call in the contract. But again, I thank everyone for being here, and specifically want to thank the library's leadership for their continued support. We have this wonderful space for anyone to come and participate in these discussions, and for all of our online viewers to enjoy as well. So again, thank you for watching this presentation on Ethereum and blockchain technology. We're going to continue to expand our financial education together and to build that trustworthy foundation where we can make consumer educated and financially literate, financially literate behaviors and good choices from. So again, I appreciate everyone. I know I like to ramble, but again, thank you so much for showing up. I hope everyone has a great rest of the day. I'll see you next time.